We already did this example. Okay, so we need to move fast here. If you're going to go, go. Just take the goggles. I don't know where my pass is. All right, so we're going to talk about preparing molar solutions. All right, so in other words, how do you actually make a solution with a certain molarity? And we're going to practice this, I'm thinking probably Friday at this point, because we need tomorrow to do some practice problems on dilution and probably take a quiz on it. Okay, so chemists have to prepare solutions in order to do the reactions they do quite often, because a lot of reactions are done by mixing two solutions together. So to prepare those solutions in the first place, a lot of times the reaction works best if you have a very specific concentration of your solution. So it's useful to know how to make a certain concentration, okay? So an example here. You have to prepare 1 liter of a 1.5 molar aqueous solution of sucrose for an experiment. A 1.50 molar solution contains 1.50 moles of the solute dissolved in water. How many grams of sucrose do you have to use? Okay? So that's, do they give you a place to actually calculate that on your notes? Do you have a blank spot there? No? Okay. Okay. Assuming that this is a 1 liter solution, which is exactly how much we have to prepare here, what that means, remember molarity is moles over liters, right? So if I have a 1.50 molar solution, and it's a 1 liter of solution, then this number up here is going to be 1.50 as well. Does that make sense? Everybody with me on that? So if I have a 1.50 molar solution and I'm trying to make 1 liter of it, then it takes 1.50 moles in 1 liter to make that solution. Okay? So I'm making 1.50, I need 1.50 moles of the solute dissolved in the water. Okay? So then the question is, how many grams of sucrose would we need to use here? And then they're giving you the molar mass of sucrose, 342 grams per mole. So what would we have to do to figure that out? This should be pretty easy. What do I do to go from moles to grams? So just 342 grams in 1 mole, right? So you multiply by 342, which I think is going to give me 513. Is that right? So then, is that what we do? We add 513 grams to 1 liter of water. Does that sound right? I guess we should make sure that it's actually 513, right? It is, okay. So 513 grams of sucrose to 1 liter of water. And you know chemistry well enough by now, you're all looking for the trick, aren't you? It's a trap. I'm trying to trap you. Why is this not right? Why is it not right to say to make a 1.50 molar solution, then I need to add 513 grams, measure out a liter of water, and then dump 513 grams of sucrose into it? Let's think about what this formula actually means. Moles of solute. Well, I mean, we know to make 1.50 moles, we're adding 513 grams, right? The key is right here. If I start with a liter of water and I dump in 513 grams of sucrose, do I have a liter of solution anymore?
No.
No, it changed the volume, didn't it? Okay? It's going to have a bigger volume at that point. Because the sucrose dissolves, right? But even though it's kind of dissolving, fitting in between the spaces in the water molecules, it's still going to increase the volume of that solution. So now we don't have a 1 liter solution anymore. Okay? So it turns out it's a little bit tricky to make a 1.50 molar solution because you have to make sure that your final volume ends up being exactly 1 liter after the sugar's been added. Well, how do you do that? That's kind of tough, right? So what we have here, well, yeah, okay, that's what we just said. And we just answered why. All matter takes up space and will add volume to the solution. Therefore, you must account for the space the sucrose will take up. So you need to have slightly less than 1 liter of water in order to make this solution. Do you guys have to fill anything out there? No? Okay. So that brings us to another formula. Usually we're going to use concentrated solutions called stock solutions. Okay, and I have a bunch of stock solutions in the back, and a lot of them are really concentrated, like the acids that we have back there, are 18 molar or 12 molar, and that's the kind of thing where if it gets on you, it will start to eat your skin, right? Very, very concentrated, okay? Those are our stock solutions. An example of that is 12 molar nitric acid, okay? HCl is 12 molar. The nitric acid stock solution is 15.8, and the sulfuric is 18 molar. Sulfuric is the one that you just don't want to get that on you. When you pour sulfuric acid into water, just a little bit of sulfuric acid into a lot of water, it will actually heat the water up so much just from dissolving that it will almost boil. The water is really hot. It's just nasty stuff. All of these are nasty, right? The nitric acid, you saw what it did to a penny at the beginning of the year, right? Remember that? It just turned it into a brown gas, basically. And hydrochloric acid is very nasty stuff, too. So those are our stock solutions. But you can prepare a less concentrated solution by diluting that, all right? So the formula that we're going to use to calculate the dilution is M1V1 equals M2V2. I think you're going to like this equation. It's not very difficult. I think you're going to like the problems that go with this equation. All right? Oh, P1V1 equals P2V2? Yeah. It reminds me of Star Wars because I'm a nerd. R2D2, M2V2, I don't know. Yeah. Well, no, not C2. Well, he's his friend. All right, so a practice problem with this. And again, you're going to like these because, and I guess we should talk about what these stand for real quick. I was too busy talking about Star Wars. M is the molarity. V is, what do you think V is? Volume, okay? So the first molarity times the first volume equals the second molarity times the second volume. And the only problem you're going to have on any of these is just making sure that you determine which is which when you read the problem, okay? So what volume in milliliters of a 2 molar calcium chloride stock solution would you use to make a 0.50 liter, to make 0.50 liters of a 0.300 molar calcium chloride solution, okay? So we're starting with a 2 molar solution. We want to make a 0.30 molar solution, and this is how much of it we want to make. All right? So we're just going to use that formula, M1V1 equals M2V2. By the way, what's your big hint that this is a dilution type of problem that we need to use this formula for? What might you be looking for in the problem that would tip you off that we need to use this formula? Okay, there's 3 numbers, so that's kind of a hint. Okay, so if there are 2 molarities, first of all, right? Okay, any of the problems we've dealt with so far have not given you 2 different concentrations. If the problem gives you 2 different concentrations, then we're going to have to use this formula because this is the only one that has 2 different concentrations in the formula. And as we noticed, the concentration is going down, right? Now, a lot of times you will also see the word dilute in these types of problems. So that's a big tip-off that we're going to use M1V1 equals M2V2 if you see that word. Okay? So those are some of the hints that you're looking for that will tell you, okay, this is an M1V1, M2V2 problem. All right? Now the second thing I would do, once you determine that, I would label everything. All right? So let's call this M1. It really doesn't matter which is which. And this is very similar to what we did with the gas laws, right? With P1, V1 equals P2, V2. So that's your M1, okay? Okay, here's the volume. Is that my V1? And that's where you have to be careful. This is the volume that goes with this concentration, right? Okay? So this is M2 and V2. So what we're actually trying to find is V1. Everybody with me there? Okay, so then when you set it up, these are nice and easy. We've got 2.00 times V1, that's what we're trying to find here, is equal to 0.300 times V2. This is in liters. Do you think it has to be in liters for this equation?
It's going to have to be milliliters.
Well, it actually, yeah, it asks for milliliters at the end. So we can convert it at the end or we can convert it now. It doesn't matter because you can plug in liters or milliliters into this. You just have to make sure that your units match. Okay? Again, exactly like P1 V1 equals P2 V2. We could use whatever pressure units we wanted as long as the pressure units matched on both sides, right? Now in this one it doesn't matter because there's only one volume. So, and we're solving for the other volume. Okay, so that's the numbers we plug in. Just divide both sides by 2, and that'll give you your volume. .075. 0.075 what? That's liters, right? Because that's the unit that we had in the problem. Okay, so now it's asking for milliliters, so we do need to change that. So do we multiply by 1,000 or divide by 1,000?
Divide. Well, you just go 3 over. Yeah, 3 to the right.
3 to the right? Okay. It needs to become a bigger number because we're going to a smaller unit. Now again, if this is not making sense to you, just do your dimensional analysis, right? Liters is what we're starting with, so liters needs to go on the bottom. There's 1,000 milliliters in 1 liter, so you're going to multiply by 1,000, which is the same thing as moving the decimal 3 places to the right. And there you go. They really don't get much harder than that. That's not bad, is it? Yeah. Like I said, I think you guys are going to be fine with these. Okay. Practice problem number 2. How much water must be added to 6 milliliters of a 0.050 molar stock solution to dilute it to 0.020 molar? Okay, again, how do we know that this is a M1V1 problem? There's 2 molarities, and there's another thing that's a hint here. Dilute. Okay, that's what you're looking for. All right, so this is our V1, right? 6.0 milliliters. So what's the concentration that goes with that volume? 0.050. So that's our M1. So that makes this our M2. Is he? Okay. We'll finish this one. So we've got 6.0 milliliters times 0.050. What's up, Lance? We'll be done with this one in a minute, and then you can get started. And then we've got 0.0. See, I switched those around. Sorry. The M in the formula technically comes first, but it doesn't matter which one of those you put first. 0.020 molar here times our V2. And then just solve for V2. So I'm getting V2 is equal to 15. And that's 15 what? Yeah, because 6 milliliters is what we started with. Is that the answer to the question? Yeah, here's where you have to be. That's the one little twist you might see on these types of problems, okay? How much water must be added to 6 milliliters? This is the total volume that we want our solution, our new solution to have. Yeah. Yep. because our new solution needs to be 15 milliliters, but we already have 6. So we add 9 to it, okay? So 9 milliliters, 9.0 milliliters of, well, I guess it would just be 9, technically.
What? See, look at 6 there. Where's that one?
Well, this is an addition or subtraction.
Oh, I hate those.
Yeah, I know.
Oh, wait, I don't get it.
So basically what we're doing is 15 milliliters minus 6.0 milliliters. So when you do that, you end up with 9.0, but you round to this place because that's the least precise on the top number, or the most precise on the top number. I'm usually not as hard on you guys on the subtraction and addition because I know that's hard to remember. Okay? All right, we'll call it quits there for today. I think what we're going to do is practice this for the beginning of class tomorrow, but I think by the time you do a few of these practice problems, you guys will be more than ready to take a quiz at the end of class tomorrow. All right?
Flash drive.